Hey everybody, how's it going? Thanks a million for coming. 15 minutes feels like an age compared to the 6-minute lightning talks last night. So, artificial intelligence will replace us all. That's something that we've been hearing a lot of over the last year or two. But is this really the case? I think over the last day or so and a lot of the talks, I think you start to understand that having a human to guide and lead these systems is really important. And I think AI won't actually replace us, but it will augment our workflows. It'll automate many menial tasks, empower us to perform actions at scale without having to eat, sleep, drink, or do any of these things, and ultimately enable us to move faster, reducing cognitive load, reducing burnout. It's great. We have ceded a lot of our responsibility and some of our own agency to AI systems and have them doing things for us almost like interns. There's another quote here: nothing brings more peace of mind than blind trust. Is that true? I don't think so. There's a reason we have the paradigm zero trust and not zero scrutiny. So what if I told you today that we blindly trust AI models to perform actions on our behalf and ultimately decide our fate? We see these things in loan approval, in insurance claims, in protecting your machines, protecting your network. AI models are everywhere, even scanning the milk cartons on your kitchen table in the morning for defects. So AI is only getting more capable, and it's able to do more with less at an unprecedented scale, only limited really by the amount of energy and compute power that you have. So with AI systems, they are notoriously black box. And we have the old Russian adage, trust but verify. But how can we do that in the age of AI? Now, when I was sitting down to do this talk, I said 15 minutes, short. It needs to be sweet. And I took a step back from a lot of the guidance that we've published in the past, a lot of the guidance that I've given myself. And I wanted to see, I guess, applying the 80-20 principle, like what 20% can we do to reap 80% of the benefit? So the way I'm looking at the, I guess, AI development lifecycle is separating it into two parts: pre-deployment and post-deployment. So the AI development pipeline looks something like this. Very simply, we have training data, it gets featureized, number crunched, put into a model, and that model is then sent around, saved to disk, deployed, and has live data run through it, where a prediction is then made, or an action is taken, or a classification, or whatnot. Very simple. Now, there is a whole cohort of risks. In the pre-deployment stage, and typically analogous to supply chain attacks, we have the risk of data poisoning. The models are what they eat. They reflect the data they were trained on. We can tamper with the training process itself to actually inflict harm, to alter and affect the model. Or we can hijack that pre-trained model and actually implement malware or hijack the control flow or even bake in logical backdoors that are very hard to detect and are quite unscrupulous. Post-deployment, we have a whole new set of risks that don't mirror kind of, I guess, traditional AppSec in a way. We have what we call inference attacks, adversarial examples, prompt injection and indirect prompt injection, and the risk of things like data leakage and data exposure are prime. So double-clicking on pre-deployment for a second, and I think this is quite important because it's something that we haven't really touched on this week. There is 1.5 million repositories on Hugging Face today. There's about 10 to 15 million files on that website. We're sharing models at an unprecedented scale. We're downloading them, we're sharing them, we're uploading them, we're fine-tuning them, we're uploading data sets, and it's fantastic. The proliferation of AI and open source is incredible, and it's something that we should keep going and continue. However, there are a whole cohort of risks. And what I want to highlight is basically that the supply chain is made up of 4 key components. We have data that the models are trained on. We have models, which are the results of this training process. We have the tooling, which is used to build these models, the libraries, the MLOps frameworks that host the serving of models and monitor them. And ultimately, the infrastructure, like the cloud infrastructure and the GPU compute that we actually build and use AI on. We see supply chain attacks pretty regularly. Data poisoning affecting models, changing models to spread fake news, or maybe changing the data sets that they're actually trained on by buying up expired domains that comprise a major data set. and then starting to infiltrate that process from the very beginning that affects the model through its entire life cycle. We see malware in models now. We see things like post-exploitation frameworks, reverse shells. We see steganography payloads. There is quite a lot of stuff happening here. And that's mainly supported through insecure file formats like Pickle, GGOF, R, Keras, TensorFlow, and even ONNX. We can leverage these things to do all sorts of nasty stuff and execute code. But what if I told you we didn't even have to execute code in the first place? We can hijack the control flow of a model, the architectural representation, to create a system that if we press the right Konami code, we can bypass all logic. Scary. Not just that, but by abusing MLOps tooling, we can leverage the fact that some of these systems that maintain and monitor and deploy AI models don't have authentication. Authentication, it's 2025. We have full exploit chains for a number of these. It's been pretty astonishing to see, I guess, how insecure these are. Why am I telling you this? Because how do you know what you're getting when you download a model? How do you know what you're getting when, or how does a customer of yours know what they're getting when you send them a model or you deploy an application with your model inside it? Today, we're missing very basic security controls around AI. We're missing things that have been around in AppSec for 20 years. You know, this is a toy example of us leveraging Pickle exploitation and steganography to hijack a malicious model. We upload it to Hugging Face or GitHub or insert it in some package. An unwitting user downloads it, runs it, and lateral movement, hey, coin miners on your GPU compute instance. But we're lacking in these AppSec the AppSec principles. So, you know, if I said, hey, we need to start scanning Windows executable files for malware, and we need to sign them to ensure trust, you'd look at me saying, yeah, okay, Eoin, we've been doing this for decades. Great. Well, why aren't we doing this for models? 1.5 million repositories on Hugging Face today. Right? How many models are being shared, bundled into applications? How many people are leveraging these tools? How many people are leveraging these models in their environment because it means they don't have to spend millions and millions and millions on their own compute, their own data scientists, their own data labeling, but they don't know what they're getting. They don't know if the model has malware in it. They don't know where the model came from. They can't trust the fact that there's a certificate which they can verify the certificate chain and say, hey, this came from one of the major model providers. And this is where we need to get to. And this is the next steps we need to take in the AI supply chain. And I've boiled it down to be very simple. I think there's a lot of incredible guidance. You know, Rob van der Veer, Aranish are going to talk later today on more specific controls. We have the SANS critical controls document. But for me, I wanted to call out some very specific things. We need to scan models for threats. We need to sign them, and we need to be able to verify them on model load. I just want to shout out the OpenSSF model signing project, which in the next couple of weeks is going to be launching finally. We have the model transparency project where you can actually test out model signing today. I'll drop a link to that in the Slack later today. So from a topological perspective, you know, I get asked, okay, where does signing and scanning fit in the life cycle? And you know, you have a choice. You can either build your own model after your data collection process and maybe fine tune, or you can download your pre-trained model, which I think a lot of people are doing today. So if you train your own model, you kind of want to scan it. You want to scan it as you're deploying it. You want to scan it before you save it to disk, just in case somebody hijacks your CI/CD pipeline. We've seen it before, SolarWinds. We want to sign it for trust because people want to know where their model came from. They want to be able to prove provenance and say, hey, if I take this model and I fine tune it, I can assign another claim to that chain and say, hey, this is the chain of custody from the initial producer all the way to the consumer. When you're downloading the model, you want to scan it for malware because you don't know what's inside it. You want to be able to verify that certificate chain and verify the integrity of the files for trust, and then you can deploy the model safely. But again, we've talked about the risk of we don't know what a model is trained on. We don't have a list of the data set, nor can we reasonably expect to gain access to that data set. And we don't know if the individual or the organization has baked in an inherent bias on purpose or by accident. So what can we do to try and demystify this black box? Well, we have to look to dynamic post-deployment testing. So I'm going to use LLMs as the example because they're in vogue right now, but these principles ultimately apply to predictive ML as well. And it's something that's very easily forgotten. And predictive ML underpins an awful lot of what we do, or an awful lot of our society. So prompt injection, very simple. We've heard about this week, so I'll skip over it quickly. But it's effectively bypassing the guardrails or the alignment that a model producer or the security solution around a model to produce illicit output that wasn't intended. You know, we see this with things like, hey, make a bomb, or hey, tell me how to, I don't know, write malware or something of the sort. And ultimately, prompt injection by itself is a bit of a storm in a teacup. And you're probably like, well, I've been hearing tons about this. And you know, you'd be right. The real threat is indirect prompt injection. Indirect prompt injection is scary because even if we don't call an LLM agentic, LLMs today are browsing the web. They are reading your emails. They are interpreting data. They're calling tools and plugins. And it doesn't have to be agentic for us to, for a model to be doing these things. But what if an attacker could compromise some data that a model takes in? The thing about LLMs is the data and control plane, which are usually separated, are fused together, which means that data can affect the control of the model. Now, what does that mean? It means that every piece of data that goes into a model has the potential to change the outcome of that model, meaning that data is now the new security frontier when we consider LLMs. Scary. So, you know, we've seen glimmers of LLM agency, and this was, I guess, you know, I'm going to call it V0.1. We have new things like, as Helen was showing, where we have multiple LLMs chained together with memory and all sorts. But the computer use aspect was really interesting. You know, Anthropic released computer use, Microsoft had OmniParser, and OpenAI introduced Operator, which can use your computer like a human. It's cool. But we could hijack this in a really, really simple way. One of our researchers in HiddenLayer, Jason, he managed to basically get Claude computer use to wipe the file system with a PDF. We also managed to send an email to Google Workspace, which prompt injected the Gemini client to suggest spam links in the browser window. Data is the new security frontier here. So what am I proposing? Again, I want a super simple takeaway because I think it's effective to cut through an incredible amount of really solid, good guidance. But what are the key takeaways if you're earlier on in your security journey for securing AI? When you're deploying a model, scan the model artifact, verify the integrity and the signature, and then deploy it into a test environment. Red team it for bias, for drift, and ultimately for security. Now, there's a caveat. We have a lot of conversations around AI safety, and rightly so. It's an incredibly important part of understanding the bias and ethical concerns around models. However, without security, we undermine all of the effort we put into baking in, or to reducing bias and drift in models. Because if I can prompt inject a model, or if I can bypass it, I can disregard any of the instructions that the model was instructed to do. We need to then reinforce it against attack. You know, this takes place in the form of guardrails. It could be basic content filtering. It could be fine-tuning. But ultimately, having a life cycle where a cyclical route for us to actually continually reinforce these is really important. Monitor for all the bad stuff, and then loop again. Now, what do I mean by monitor? Because that's a big thing. So logging is key. It's incredibly important when we consider the traceability and auditability of models. With agentic, this becomes even more important. With agentic systems, we're going to have multiple agents communicating with one another, performing actions. What actions took place? What are they saying amongst themselves? Do we have any path to reproduce what happened? If an incident occurs, where something is, you know, a business critical event happens or a material event happens to your business, like, do you just say, yeah, the AI did it, sorry? No, you have to have that logging, and you have to log every single communication as much as you can. However, it gets tricky. And unfortunately, I don't have enough time to talk about that, but there's different logging techniques that we're going to have to employ. How do we, ensure that there's no PII inside these things, and ensure that, basically if there's a crazy amount of requests to an LLM, that we don't end up, having to save every single thing. We need to monitor for prompt injection, because any data that goes into a model could be treated as untrustworthy. And ultimately, indirect prompt injection is the real risk. But we put a lot of focus on the input of the model, and rightly so. But ultimately, who cares how we got there if the model produces an illicit outcome? Now, we heard yesterday that we're going to need more LLMs to understand the lexical content of the prompt or the question and the answer as a result. And that's what we're going to have to converge on. We have to understand that this is the new reality. Ultimately, we need to ensure that data leakage is not taking place. Sensitive information leaving your environment is super important. But again, plugin and tool calling is where an LLM can be turned into an insider threat. We talk about interns, or LLMs acting as interns, but these LLMs will have the same access and privileges unless we implement things like role-based access control and the principle of least privilege. We need to ensure that their controls are completely minimized, or that their abilities are minimized. So key takeaways. With model assets, we need to use safer model formats. Safe tensors is usually a good one, but understandably, we're locked into the libraries that we use, and we're going to have to move towards scanning, signing, and verification. This is super important for us to secure the AI supply chain and will act as the fundamental building block for the future of the AI development lifecycle. When you're deploying a model, if in doubt, log it out. Models exist in the context of their system, and you need to threat model accordingly. If you have an LLM and you red team the base model, sure, that's important. But when you deploy that base model or foundation model into your environment and you fine tune it or add create a system prompt, you need to understand the effects of that model in your system. What's going to cause a business critical outage? What's going to cause reputational harm? And these things have to be modeled specifically for the context in which you're using it. Ultimately, we need to monitor for prompt injection, for signs of misuse and data egress, which is a vague call to arms, but we're going to see some fantastic guidance later today, in fact, even in the next presentation. And ultimately, our challenge is to take non-deterministic black box systems and make them secure. Let's get to work. Cool. Thank you.